So I think I sent out the test to you guys already. With your email address, your college email address, and then is your test 3 is also posted in D2L. So make sure you guys do the test. You got 24 hours to do the test. Submit your test to my email address, and don't forget, use your cam scanner. You can only please submit your test. You're only allowed to submit a test with only one PDF file, not multiple PDF file, and I won't take any picture files. So don't take a picture. So download a cam scanner or something else and then submit it to me. So you need to do that. There is a video posted there, so on YouTube. So please use a cam scanner and give it to me, because this time I got 150 tests to grade. It's gonna be a lot of tests for me to grade. So I'm really busy starting tomorrow. Really, I don't have time to check your emails and everything because I will be so busy with grading a test. So we'll talk about chapter 12 here. That's the last chapter here. So I'm going to share the screen here. If you have any questions, you can type into your R there. So type it into your chat room here. So if you have questions, type into me. So chapter 12 is where we do what we call as an analysis of variance. So this is where we do what we call as an F distribution. So this F distribution is is another distribution. So right now you learn around 4 distribution: the Z distribution, the T distribution, the chi-square, which is on chapter 11, and then on chapter 12 you get what we call as a F distribution. And again, F distribution is very similar to chi-square. It's not symmetrical and it is a right skew test. The value of F distribution cannot be negative. And the exact shape of F distribution depends on 2 degrees of freedom. So you find out that the F distribution and the chi-square distribution that you learn in chapter 11 are very similar. They are skewed to the right, they're not symmetrical, you cannot have a negative values. The only difference here is your F distribution has 2 degrees of freedom, 2 different degrees of freedom, where chi-square only have 1. So when you guys want to find your critical value, you need to give 3 things. Last time we only 2 things. One is 1 minus alpha and then the degree of freedom. This time you do 1 minus alpha with 2 different of degree of freedoms in this case. So the analysis of variance, we got 2 types. We call one-way ANOVA. ANOVA means an analysis of variance, which is learned in 12.1. And then 12.2, we do a 2-way ANOVA. So what is the difference between a one-way and 2-way ANOVA is one-way ANOVA is you only have 1 characteristic. Or another thing is you only get one category or 1 factor. But you have to have 3 or more populations, and we are talking about the mean here. So I'm going to summarize everything at the end of class, what is going on in each chapter, so you guys know which one is which. So that is very important, because when you do your finals, everything is jumbled up. Although it's 50 multiple choice question, you need to know which one is which. So for ANOVA, this is done for 3 or more populations. So mean. So this is with 1 factor. The requirement is the population has to be approximately normal. So in this case, it's loose. So if this requirement does not met, you have to use a Kruskal-Wallis test. This is in chapter 13, which we did not cover. Population have to have the same variance or same standard deviation. This is also considered loose requirements unless that your data differs a lot. And then the third requirement is simple random sample. It has to be a quantitative data. The samples comes from an independent, not matched pair, or not dependent. And then it has to categorize in 1 way or 1 factor, we call it. So these are the requirements. The first 2 requirements that you have here is loose. So if you did not fulfill these 2 requirements, it's fine. But the last 3 requirement is absolute must. So these last 3 requirement is a must to fulfill here. Your claim statements is fixed. This is your claim statement. Your hypothesis statement is fixed. Your null hypothesis mu1 equals to mu2 equals to mu3 equals to mu k, and then your alternative is at least one of the means is different from the other. So this this is always fixed. Okay, and usually your claim statement is belongs to your null hypothesis. And then the decision is the same thing. If your p-value is less than alpha, we reject. If p-value is greater than alpha, we fail to reject. When you reject your H0, we say that is sufficient evidence to warrant rejection, that all the means are equal. And then for fail to reject, that is not sufficient, that all the means are equal. So this is something I need to point out to you guys when you do a one-way ANOVA is when you do conclusion on the very last place here, you cannot use the word different. Okay, a lot of people change with the means are different from each other. You cannot use the word different from here because it's very important. We always use the word equal or the same. And then make sure that another thing that about the caution here is make sure you have a population. So you have to have, when you make a conclusion for a one-way ANOVA, the word population has to be there and the word equal has to be there. You cannot use the word different here because if you use the word different here, we are not doing the correct conclusion in this case. So your conclusion is always equal. The reason why we always use equal is because your claim is always equal in this case. So that's the reason why that when you guys do your conclusion, make sure you use the equal word, not the different word. And then because this is, as you guys know, that one-way ANOVA is doing 3 or more populations. So a lot of students think about, you know what, we learned something in chapter 9 for 2 population. So why don't we just do it 3 times, you know, mu1 with mu2, mu2 with mu3, and then mu1 and mu3. So this is the example that we have that some students doing multiple tests for 2 that you learn in chapter 9. So you do mu1 equals to mu2, mu2 and mu3, and mu1 and mu3. Well, that is cover everything from mu1, mu2 if you have 3 population. Unfortunately, if you do that, this is what happens. Your confidence level will actually decreasing. So if you are doing a 95% confidence level or 5% significant level, if you're doing these 3 in a row like this, your confidence level will actually is 0.95 to the power of 3 because and you will get 85.7%. So what I'm going to tell you here is that so if you guys going to do multiple of 2 samples, if you are doing this, you will figure out that your significant level in this case will go down. You don't have a 95% anymore. You only have 86%. So that's the reason why that when you guys do this kind of ANOVA, we do all 3, 4, 5 populations at one time. We don't separate them in 2 samples like what you did in chapter 9 because your confidence level will drop in this case. Okay. The degree of freedom, the new K is the number of categories, N is your sample size. So the degree of freedom for numerator is K minus 1 and the denominator is K times N minus 1. So usually in your R, they will give you the degree of freedom, so you do not need to worry about it. So again, how you find your critical value is always a right tail. In R, you do QF, 1 minus alpha, K minus 1, and Kn minus 1. So the 1 minus alpha is the first number you have to put in, which is your alpha, sometimes 5% or 1%. And then K minus 1 is the numerator degree of freedom. And then Kn minus 1 is the denominator of degree of freedom. So in this case, you have to enter 3 numbers. In this case, that means you're going to have 2 commas here. Okay. For R, if you have data is given to us, then make sure that you use A to read table. And then you assign X and Y. But watch carefully here that this is very important. When you assign, your X variable here has to be a quantitative variable and your Y variable here has to be a categorical variable. So if you switch your X and Y around, means that if your X is a categorical and Y is a quantitative, when you do your R, they give you error message. So when they give you error message, that means that you switch your X and Y around. And then you just type ANOVA LMX tilted Y. So this is how you find doing one-way table here. We do not do this, so do not need to do this. So if a table is given to us, what you need to do if a table is given to us is you have to enter your table into Notepad. Okay. So if a table is given to us, you have to use Notepad to enter your data. Okay, so you have to rewrite the table into Notepad. I will show to you how to do that. And then once you finish writing your table in Notepad, then you do the same thing what we just did on A. Okay, so I just want to point out to you that this this chapter 13, you might need to use Notepad here, and you might have to type it in. Okay, not copy and paste. When you do the ANOVA LMXY here, this is where you will get. This is what the table you will get. You will get only two things, S and residual. S in this case, this 2 is the numerator degree of freedom. This 18 is the denominator degree of freedom. Remember, we have the K minus 1 and Kn minus 1. So this 2 is your numerator, K minus 1, and this 18 is Kn minus 1. And then this is your test statistic, and this is your p-value. So majority of the how you read this is you need to watch. Those are a few important stuff that you need to know. So mostly the rest of them you do not need to worry about it, because if you are doing real statistic class, if you are a statistic major, then yes, then we talk about the sum square and the mean sum square. So those are the different types of stuff. So so in order for you to find the critical value, you use QF. 1 minus alpha, let's say alpha is 5%, and the degree of freedom here, numerator is 2, so you use 2, and then 18 is your 18, and then you use your R, and that's how you figure out your degree of freedom in this case, your critical value, your critical value in this case. So we're gonna talk about your homework here. So does anyone here has any homework questions for me in 11.1? 12.1. Let's talk about 12.1 first. Anyone have any homework question for me in 12.1? Anyone?
No, I think I had a question. This is Greg on 12.2, but it was on entering those tables.
Wait for 12.2. We're just talking about 12.1 now. We'll talk about 12.2 later on.
Okay. I think I'm good.
Okay, so I'll just do one example here so you guys know what to do here. Okay, you got this type of data here. Okay, so this is 12.1 question 5. So this is your table here. So, so a lot of us were just like, okay, I'm gonna open this on clipboard, and then I copy this, and then I paste it on Notepad, right? This is what you guys do a lot. Good. This is all. So this is not a good thing to do in Notepad. So if you're doing this question in like this in Notepad here, you will get everything wrong in your R, and you will get errors or some type of stuff. So how do you do this in your Notepad to get it correct? First thing first is you have two types. One is a type A, type B, and type C, and don't forget they don't like this. So in order for us to do this is talking about types of vehicles, right? So I'm gonna do this is types, and then the next one, this number 8188, this is the greenhouse gas emission. So I just use gas, okay? So what you need to do here is you have to do type A. I'm just lazy, right? Type A. So the type A is 8.1. So this is how I do, this is what you need to type in your Notepad. So type A is 8.1, and then type A again, I'm gonna go down, 8.8, and then type A again is 8.9, and then type A again is gonna be 9.1, and then type A in this case is gonna be, so you're gonna do this. This is the only way, otherwise if you wanna do the other way, it's even worse. So this is how you have to key in your data. So so if one of these is wrong, then everything is wrong in this case. So some of you wants to say, can I do this in Excel? Yes, you can do this in Excel, but then after that you have to export it into Notepad here. So you can do it in Excel because Excel is a little bit faster. So what I did here is all this is in type A, and then I'm going to do type B because that's the next one. So I have found type B 2, 4, 6, 8. So I got 8 of these. So I can kind of do it quick. I hope I can copy and paste this up. Nope, cannot be copy and paste here. Unfortunately, it's a bit more. So this is, yeah, this is where I say a bit more work here. is you have to type all this. This is also same with the next section, 12.2. So you have to type in quite a lot of numbers here. You guys got what I'm doing here, class? You guys got what I'm doing? And yes, if I come out a table like this in your test or in your finals, you do have to type it out like this. So this is all type A. Now we do type C. How many type C we have? We got 9 of this. So that is 5. Again, you can use copy and paste if you want to make your things go faster. And then now we do the type C. So type C in this case will have 8.3, 9.3, 8.2, 9.1. Hopefully I type everything correct. 9.8, 9.2, 8.7, 9.5, and 9.7. So this is all the, so this is in question 5 here. So make sure you delete this type here because I don't need this anymore. So this is the one that we will use. So the types are here and the gas is over here. So make sure you save this. I'm gonna save as, I'm gonna put this as 12.1 just for the heck of it. Okay, so exist, okay, fine. So this is 12.1, so this is the, so the first thing we're gonna do here is picking the hypothesis statement. It says that based on these measurements at all, the units are tons per year, and you have to use the claim to test the claim that the different types of vehicles is same amount the greenhouse gas emission. So how do we do this for your hypothesis statements is mu1 equals to mu2 equals to mu3, and at least one of these means is different from the other. Since we got 3 types, type A, type B, type C, so that means you got 3 population. So this is the one that we will do for the hypothesis statement here. Now you need to do your F distribution, figure out your test statistics. So first you have to type all this in there, and then you use your R, okay? So when you use your R, make sure that you use A equals to read table. Don't use X, don't use Y, or don't use anything. Use A in this case, then file choose header equals to true. And then you pick, this is 12.1, so we're gonna do 12.1 here. So just press A, enter, and see if all your data is been, so we got types and gas, so we got everything imported here correctly. This is a crucial point, how you do X and Y, because if you do this wrong, you get it wrong. So don't forget, X is for quantitative and Y is for categorical. So can you tell me which one of these is quantitative and which one is categorical? One of them has to be one. So who knows which one is which? Categorical is your types or your gas?
You've got 3. The quantitative is the one with the decimals, correct?
Yes, the quantitative is the number. Yes, so that means that will be your gas. And your categorical in this case will be your types. So in this case, in your R, your types will be in categorical, so it has to assign to Y. And your quantitative gas will be assigned to your X. So in your R, you will do X equals to A, money sign, I think gas is 1, okay, capital gas. So this is quantitative, Y equals to A, and then this one is types. Okay, and then once you assign them, so you can tell if you hit X, you find out these are all numbers, quantitative, and if you hit Y, they're all categoricals. That means they are variables, or in this case, categories. So what you do next is you just finish this, and then you do ANOVA LM XY. Okay, don't forget it's XY, not YX. So it's ANOVA LM XY with 2 closing parentheses. And this is what you will get in your analysis of variance, your ANOVA. So your F is here and your P value is there. So this is, so the question is asking us for the test statistic F. So in this case, it's 0.0154. Oh, 2 decimal place. Didn't read the question carefully. So 2 decimal place is 0.015. No, 2 decimal place, sorry, 0.02. Didn't read the question carefully. And then after that, you have to find the p-value. The p-value is the one next to this right over here. It's 0.9847. So in 2 decimal place, this is 0.98. Okay. So so this is how you find that. So now you use the alpha here. So since your p-value is greater than alpha, so what happens if your p-value is greater than alpha? Do you reject or do you fail to reject?
Fail to reject.
Do not reject, okay. And what do you conclude, that this type of vehicle, it does or does not appear to be a fact? Okay.
Does.
Okay, this is something I want to point out to you, those students who like, oh, there's not. So if you reject H naught, then it is a fact. Okay, so this is something you guys need to know. If a question is asking, does that a fact or not? If you reject, then it is a fact. If you fail to, oh, this is not. If you fail to reject, then it does not. Okay, if you reject, a fact. If you fail to reject, it does not. So make sure you guys know that this is very important. So if you reject, if you fail to reject, then you will answer does not affect. Okay. So based on this, since you fail to reject, so it should be, it does not appear to be a fact. You guys okay here?
I think so. I think I typed one of my values wrong on that in the tables. That's why
if you type right. Yes, if you type one of the value wrong,
I'm gonna go back and find it.
You will get everything. You will get your answer wrong. So that's the reason why that you have to check this question really carefully. Okay. So the main part of this is not that tough to do, right? But the main part that you have to do is doing this notepad here. So this is a part that a lot of students get wrong here. It's not because of this, it's because how you enter it from the notepad. So I just want to tell you guys that this one, the entering your data in notepad takes more time than doing this question.
And there's no faster way?
No.
Okay.
No. The other way is even worse. I'm not going to show it to you. Okay. So so you have, this is the only way to do this using R. So you guys are doing all right here with 12.1. This is pretty much very simple. So again, this is the nicotine. Oh my God. Okay. Unfortunately, this is one you have the entering the data here will be another pain to do it. So does anyone know how to enter data for this case? Let me just export this into here. Anyone know how to enter this data into the way that we want?
3 categories.
So what kind of categories do we have here?
K, M, and F, maybe?
Yep. So so you got types. So make sure you have your context. And what is this 1.6 and 1.2 and 0.9, 1.1? Those are what we call as your nicotine, right? Amount of nicotine. So I just put nic, short form. So anyone know how to type in this? You know what? Maybe I should just do something more easier. So you guys, I do nic here. And then I do type. This is probably easier. So this is all for the cake. Oh, no. This is actually worse. I don't know why they do that. Oh. All right, so actually it's the, nah, doesn't matter. I'm just hoping that they might copy it. Yeah, your Word, if you do this in your Excel, so this is something I want to tell you. If you guys have Excel at home, this is what you guys do. I think Excel will be quicker in this case. So I showed you the fastest way, and then after that, you just save it as Notepad here. So once you guys do this Excel, this is actually faster way to do that. And then you paste your data into here, right? And then what you need to do, because we had to rearrange this, I'm going to cut this and paste it somewhere else. because I need to arrange this in. So the first one you have is the type, right? And then this is nicotine. So so the type, the nicotine is all this. So what you do is you can copy and you can paste here. See, this is easy.
Gotcha. That's cool.
If you have Excel, you have copy, paste. Wait first. I'm gonna do this. So this type is called king size. So I just use king. And the good thing about using Excel is if you type king, if you just type capital K or K, they will automatically label that for you. It's quicker. And then this one is copy and paste. And don't forget, you have to, so this is quicker in this case, right? And then this one is gonna be considered what do you call that? The mantle, right? So you can use mantle. Maybe it's too long. Yep, maybe it's too long. I'll just use ment. And then I just type M, the letter M, and then they will all, so it's very quick actually if you use Excel. And then the last one is the non-mantle. So you just copy and paste this over here. And I just put none, just, you know. So you actually, you're done. And then what you do next is, I want to see if I copy and paste it into I'm gonna copy this.
And the moment of truth, I see.
If I paste it in Notepad, what do I get? Just for the heck of it. Yep.
Nice.
And then you're done. So you actually, if you have Excel, I will recommend you to use Excel to type all this because it's quicker, very quick, right? You do not need to, and you don't get any typo here because we use all the data here. So, and then, yeah, I think I will recommend you guys to use Excel, which is a better, if you have Excel. Otherwise, if you don't have Excel, then you have to do what I just did early on. And then you say file, save this, and then in 12.1, and then you go back to your R and do the same thing.
Nice. That's going to be very helpful. Thank you.
Yeah, I will recommend that. Okay. You guys have any questions? You guys okay here so far with this? Again, for your null hypothesis is always equal. You didn't even read the question. I really know that this is always equal. And then this is say what, at least one of these is different. I didn't even read the question. Again, your hypothesis statement is always going to be the same like this. Okay.
Now, why is it you can't say one of them is more? You just have to say at least one is different. But if
because we are testing same, so that means that they are not equal to. They are different. We are testing for the same here. We don't test about greater or less. This is our test, your claim. So all your test or claim is testing for same. Same means equal. And if you test for equal, then the alternative has to be not equal, or in this case, different. And the reason why we do not want to put this, we do not want, because if you want to put this, then you have to write down mu1 is not equals to mu2. And then so if you want to write that out, then you have to do all the combinations. Mu1 is not equals to mu2, and then mu1 is not equals to mu3, and then mu2 is not equals to mu3. So this is what you need to type for your alternative hypothesis, which is a lot of work. So that's why this is only three population. Do you know what happens when you have 5 populations? You're gonna type this like 10 times longer because you're gonna do all the combinations for 5 populations. So instead of doing that, so we just say that at least one of these is different. Okay, so that is, and again, we are testing for same. We don't test for, in chapter 12 here, we always do equal. And don't forget, I think you guys learned it in chapter 8, right? If you do for equal, your alternative is always not equal, right?
Correct.
So that's why, again, we don't do greater less in this chapter. We're always equal or not equal. So the rest is pretty much the same as what we just did. So you just do your read table and then pick the 12.1, and then make sure that you got all this. We got all these different kinds. So make sure it's and then assign your x. Don't forget your x has to be in quantitative. So in this case is Nick, numbers. And your Y in this case is categorical. In this case is type without the S. So make sure you guys got that. And then you do the LM, ANOVA LM. So this is what you get. And this is your F and this is your p-value. I just want to point out to you guys what happens if you switch your variables around. So if you switch your X is type and your Y is Nick, now you switch your variable around. When you do the ANOVA LMX, this is what you get for your warning or error. So if you came out this error or this warning, it's just telling you that your variables have to be switched around. So what you do here is either you switch your variable around, or you use ANOVA LMYX. You switch that two variable around. You still get the same answer. Okay. So this is how we do this homework 12.1 here. We call this as one-way ANOVA. So so we're gonna continue with 12.2. This is a two-way ANOVA. So what's the difference between a one-way and two-way ANOVA is two-way ANOVA, you will have what we call as, you got two categories or two factors in this case, okay? So when you have a two-way ANOVA, you will have actually doing what we call as a two factors. One-way ANOVA, you got one factor. This one you have two factors. And that means that you have to have categories. You got to have two categories that we consider in two factors. And you are showing if there is an interaction on those two factors. And if there is not an interactions, then you want to figure out if there is an effect on one of those factors. Okay. So when you guys do a two-way ANOVA, you have to do up to 3 tests. So those students are doing a project that's using a two-way ANOVA, you have to do up to 3 tests. The first test is doing, is there interaction between the row and the column factor? And then if you have, so in this case, if you have an effect, oops, sorry. So we are doing interaction between row and column factor. So if you find out that yes, it has an interaction, you stop. But what happens when you have no interaction? Then you have to do step 2 and 3. So this is what happens when you guys do this, what we call as two-way ANOVA, is do we have an interaction or not? If you find out that there is an interaction, you stop. How do you know that it's an interaction? It's very easy. Your p-value should be less than alpha. Okay. So when you look at your p-value, if a p-value is less than alpha, that is an interaction, you stop. How do we know there is no interaction? It's very easy. Your p-value is greater than alpha. That is how you figure out. So what usually we do when you do a two-way ANOVA here, once you get the result, you look at the interaction first, and you figure out if your p-value is less than or greater than alpha. If it's less than alpha, you just quickly say that it's an interaction, and you do not need to go to the other two tests. But if there is no, if a p-value is greater than alpha, then there is no interaction. You have to do step 2, step 3. Step 2 in this case is asking is does that an effect on your row, and that is an effect on your column. And again, it's very easy to figure out if there is an effect. If there is an effect, p-value has to be less than alpha. So this case, so if you want to have an effect, so if you have an effect, your p-value should be less than alpha. And then no effect is p-value greater than alpha. So this is for both row and column. So it's where sometimes you just look at your result, you can tell there is no interaction, there is interaction, there is effect or not straight away without doing any work at all. Okay. So requirements, again, there are 6 requirements here. The first 2 requirements is the same requirements. Mostly everything's the same as the first one that we talk about. It has the population has to come from a normal distribution. Again, this is loose, robust. The population has to have the same variance or same standard deviation. Again, this is robust or loose. This is a simple random sample that has to be a quantitative data. it has to be independent. And then this one is important. It has to be two-way. Two-way means you have to be two factors. And the last one is it has to be what we call as a balanced design. What is the meaning when I say balanced design? A balanced design means that you have an equal amount, like the one that we have here. This is what we call as a balanced design because we have equal amount of your of the numbers. Okay, you got 10 here, 10 here, 10 here. That is called balanced design. In order for us to have not a balanced design, so this is what happens when you have a not a balanced design. So this is so that means that your data is a bit short like this. So if you have this kind of data, this is called not a balanced design. It's because it doesn't have equal amount of data sets. Okay. So for this, for one-way ANOVA, it does not say that it has to be, so no balance. So in one-way ANOVA, you do not need to have a balanced design. Okay. But a two-way ANOVA, you need to. Okay. So one-way ANOVA, if you refer back to one-way ANOVA, it doesn't say anything about the requirement saying that it has to be a balanced design. Okay, it didn't say anything about it, right? It didn't say anything about the balanced design at all. Okay, it doesn't say only one way or one factor. But for two-way ANOVA, it has to have a balanced design. So this is very important. If you don't have a balanced design, you are not able to do two-way ANOVA. So what is a three hypothesis testing here? The first hypothesis testing is testing there is or there is no interaction. So they call it interaction in this case. Interaction means two together, both. So the null hypothesis is that it's not an interaction. The alternative that is interaction between the two factors. So this is talking about both of them. And you do not need, and then they ask you for p-values and f. Again, your p-value is less than alpha, you reject. This is the same thing that what we did all the time. We fail to reject. So if your p-value less than alpha, there is an interaction, you are done. That means that you stop, you don't continue. If a p-value that is greater than, there is no interaction, and you have to continue to step 2 and step 3. Step 2 is the test for the rho factor. So this is no effects on the rho, and then there is an effects on the rho. And then again, in this case that, the conclusion is your p-value is small, there is an effect on the rho. There's p-value is large, is no effect on the rho. And then the next one is doing column factors. There is no effects and effects on the column factor. Same thing, p-value is small, there is an effect. P-value is large, there's no effect. So when you guys do all these 3 steps, once you finish all these 3 steps, you have to give me a final conclusion. So once you finish this, you have to give me a final conclusion. What is this final conclusion is about? This final conclusion is telling me that first, does it have interaction on both? Does it have row effects? Does it have column effects? So you kind of like doing what is a summarize of everything you do. So when you talk about interaction on both, then you're talking about this one, yes or no, like the first step. And then when you talk about the row factor, that is the second test, either yes or no row effects. Then you talk about the third one, that is row effect or not, column effects or not. So this is so your final conclusion is actually has to be done after that. Okay, once you finish all these 3 tests, you have to do a final conclusion in this case. So note, one-way ANOVA is not two-way ANOVA is not one-way ANOVA done twice. So that's why when you guys do a one-way ANOVA, make sure it's one way. Two-way ANOVA, you do 2 ways. So you cannot separate this. Oh, 2-way, I just do 1 way twice. You will get everything wrong. Okay. In your R, well, this is very watch out for your R here. It depends on the data set. Sometimes the data set is labeled, like this one, we label them nicely, king, mentor, and non-mentor. So if you label this like this, then you do not need to worry about what I just did over in A here, all this. But sometimes the textbook or the data say they label this as type is 1, or the king size mentor, whatever is 1. They use the mentor one as 2. and then they use the non-mental one as 3. Okay, so if your data is labeled 1, 2, 3 like this, means the type 1 is for king size, 2 for mental, and 3rd for non-mental, then you have to do what I written down here. This is something that you have to do if it's not written down. So you have to do this labels for this case. Why we need label here is because if you do this kind of work, this is considered quantitative, 1, 2, 3. That's why your R will read the type as quantitative, 1, 2, 3, because 1, 2, 3 are numbers. So they read as categorical has to be like king and this. So what happened is you have to label this like here, M money sign label is type. Levels is 1, 2, 3. We got 1, 2, 3. The first one labels C. The first one is king, so you have to write king here with quotation. The second one is mental, man, M-E-N in the quotation, and the third one is non-mental, none in quotation. So this is what happens when because some of your data that I give it to you, like the bears and the M&Ms, okay, and all those things, they are in 1, 2, 3 types, means they didn't label them as king, mental, or non-mental. Then you have to do it in this case. This is how we assign your levels 1, 2, 3 to a different labels. Okay, so that's why I suggest you don't do this. Don't worry about this. That's why when you do the type, don't do type 1, 2, 3. You just put down the name because it will be easier for you. Okay, and then make sure also that you need to know your A and B has to be categorical. Your X has to be quantitative. If you switch your category and quantitative around, you get the error message that I showed to you. And don't forget, A is always for the row. B is always for the column. And X is always the measurement, a number. It's a quantitative. So if you switch your row and column around, you will still get the same answer, but your results will be switched around. So that means that your row become column, your column become row. Okay, so make sure you guys know which one is row, which one is column. So if I give you data set like this, where's the data set? Data set like this is what we call as row, and this is what we call as column. So do not switch. Usually they provide your data set. Make sure you know which is row, which is column. This is row, okay, and these are columns. Okay, so if you switch them around, then your answer is wrong because you probably switched them around. Okay, so then you do the summary AOV X A tilted B. So this is how you do this. Again, you do not need to do this. So if your data is given in table form, like last time, use Excel, and then after that, import it to Notepad. So this is what we do if your data in the table form. What we did here is when you type the summary AOV XAB, you will get this table. So again, this is for row, this is for column, this is for interaction. These are the 3 important parts. So this is the degree of freedom for the row, column, and interaction. This is the test statistic for the row, column, and the interaction. And this is a p-value for them. Okay. You can tell already by looking at this. This is big. So if this p-value interaction is a big p-value, you have to move on to do question 2 and 3. You can do a final conclusion from here. By looking at this, you can tell there is no interaction between AB. There is no effects on row, but there is the effects on column. How I know there's effects on column? Because this number is less than 5% if I use 5%. Okay. So without even doing the hypothesis testing, I can tell what's going on with this once the results came up. Okay. Anyone have any questions for me before we continue with your homework here on 12.2?
I did have one question for the categorical variables. If we put a number 1, 2, and 3 in quotation marks when we're typing like a factor,
it's still
won't.
I will not want you to do 1, 2, 3. I want you to type in what is 1, 2, 3. 1 is, you know, yes. 2 is no. 3 is maybe. You know what I mean?
Okay.
So yeah. So do not, and again, export to Excel because it'll make your life easy.
Yeah, I'll try the Excel. I did this problem and I made that table and I got
Number
the
4?
same F
Is that
value.
number 6 is the one that you have question, right?
I was stuck on 12.2, but I think I entered one of my numbers wrong. I'll try
Yep.
it with Excel and
Yep.
I bet I'll
Yep.
get it
Do
right.
Excel, because once you enter one there wrong, you got it wrong. So this is the data for this case. The CompuTable data list measure self-esteem for students project to figure out that how low target self-esteem and the subject, how low or medium high. So this is a lot of data you have to enter in your notepad, but I really recommend you to export into Excel. So you can open Excel if you want, because it makes your life quicker. And let's copy and paste easier. Clipboard, clipboard. And oh, this is nicely done. Copy and then paste it to Excel. I'm gonna get rid of, let me start a new one here. Paste it. So this is really nicely done for your notepad, but it's a lot of wordings. So response is too long, so I will shortcut this to res. So these are nicely done. Then row factor, I just type row because row factor is too long. Column factor, I type column. Sometimes even people are lazy, you just use C and R because that's your row and column. And then this is target low. This is all target high, right? Where's the target medium? There's only low and high. Okay, so target high. So you have to short form this now. Let's do target low. So all this target low. So you just highlight this all the way to target low, and then you change it to TL, short form. I know they change everything. Anyone know how to change? So I sometimes I just copy this, and let's see if I paste this, if I got it. Yep. So I just paste everything here to TL. So this is a very easy way for us. Again, the reason why you cannot use this because it's too long. Okay. And then this is TH, target high. So Excel is really quick if you, that's why, and the error when you make, chance of you make an error is really slim here when you use Excel. So I'm gonna copy all this to TH, paste it. All right, so, and then you do the SL for subject low. You guys doing all right here, what I'm trying to do? And yes, in a test, if this coming out, you have to, this is how you're gonna do it. SM for subject medium. Yeah, I would recommend to use Excel. That is the fastest way. Paste it, and then subject high is SH. Copy and paste all this. Oh, that's more. Paste. So it takes, I told you, this takes more time than doing your, paste all this here. This is SL. So unfortunately, this is the only way we can do this because of your data set. Paste your R. And this is SM. Copy and then paste. Questions with you guys? Anyone doing well?
I think I did this one. I don't remember if the homework took it or not. I think it did take it.
And then you copy the whole thing and then you paste it into Notepad. So you should have 3. Last time you got 2, this time you got 3 because this is called a two-way ANOVA. And then you will save this. So I'm going to save this as 12.2. And then I use my R. So so the first question they're asking here is to write the interaction. So for us to write the interaction, so if you look at the two-way ANOVA, for the interaction, there is no interaction and there is an interaction. So no interaction for now. So for this case, there is no interaction and there is an interaction. So this is pretty much very easy hypothesis. Now you need to use your R here. So we will use your R to find your test statistic. So again, use the read table. I use A, you can use M, you can use whatever variable. Do not use, no, I cannot use A here. Because why the reason why we cannot use A here is because we use A here for ABX. So I had to use M. So you figure out I'm using M here. Because we're using ABX here, so this time we had to use M for this case. So so I'm going to change this to M, just a variable. And then we pick the 12.2. And then just press M, enter, and you find out that, yes, this is what we have. Again, this is your row, this is your column, so that's very easy. So A is your row, so it's capital R. A equals to M money sign capital R. This is your row. B is your column. B equals to M money sign C. That's your column. And X is your quantitative, which in this case is all this number, the 1, 2, 3, 4, 5 that you have. That is res, R-E-S, capital R-E-S. So now you got all this into your ABX here, and then you do summary AOV, XAB, A times B. So make sure you have copy down all this the same. So it's summary, parentheses, AOV, X, this little tilted sign, A times B, double closing parentheses. So this is what you will get in your results. Again, this is the last row is the interaction between both A and B. This is for column, this is for row. Don't forget A is row, B is column in this case. So what we do here is the F in this case is going to be 11.42. In 2 decimal places, 11.42. And your p-value in this case, this is considered 0. This is a scientific notation. Since this is less than your alpha, so we will reject the null hypothesis. So p-value is less than alpha. So if you reject, there is sufficient evidence to warrant rejection. So if your p-value is less than alpha, like what we show you here early on for the interaction case, if your p-value is less than, then there is an interaction and you stop, you do not need to continue. So in this case, there is appeared to have effect of an interaction. And you're done with this question. I don't know why they want you to continue doing it. Usually in my test, if you say this is an interaction, you're done. You do not need to continue anymore, okay? But since the question wants you to continue, so now we do the row factor. So the row factor is the same, and the row, at least one of them is different. It's the same, not standard deviation, same mean. So in this case, it's B. What in this case, this test, D actually. In this case, the test effect from row should not be done because this is appeared to be effective. So you do not need to do this one. Oh, yeah, there you go. And they still want you to do the F. So for this case, the F, you just do the row factor F. So for the row factor F, is the first one, which is 8.8483, 8.4. Oh, you know what? Should not be done. Hello, because we don't need to do that. So anything not be done. So you can ignore all those things. So yep, not in done, not be done. So this is easy. Just pick the last choice, not be done. You guys with me here?
I think I'm with you. I left off on that problem and I did it again the same way you just did, and I get the same F value, but it told me it was wrong. Maybe I'll just have to try another data set.
Yeah, maybe try another data set, or maybe maybe use Excel, because maybe that's a lot. Look at the data, and if one of these is wrong, everything is wrong.
Or maybe my F value is off by the one last digit because it's 2%.
Then you type in a number wrong here. Like if you F value is off by 1, like if you get 11.41, that means one of these numbers in your data file is wrong. So I
Mine isn't,
recommend
but
you,
when I did the problem, I had different data and my F value.
yeah, I know. If you type one of these wrong, you will get different answers.
Okay.
I can tell you, okay, I'm going to change right now. I'm going to change the first one, 5, to become 3. Let's see how different does it change. I just changed one number, right? It will change. A, B, and X. Then I do my ANOVA. You can tell it changed a lot. One number. Do you see that? Compare these two. I just changed one number. I changed the 5 to 3. This is what happens to it. So that's the reason why that make sure you guys type in carefully, because if one wrong number, look, everything is different. So use your Excel to do these kind of questions. I recommend, really highly recommend to use Excel.
Yeah, that must have been it. The correct answer for me was 4.41 and I had 4.28. So
yep. So probably one of them is wrong.
Must have been.
I can guarantee you that, because you enter so many data in there. So so the rest looks the same. So I'm going to try to figure out one that you have to do both of them. Let's do question 5 because it has all this data here. So this is the last one that, so copy to open to clipboard, copy, and then paste it to Excel. I would really, really recommend you to use Excel because it's going to make your life really easy. Otherwise, you will having a hard time.
I've got Excel. I can't wait to do that next time. That's going to be faster so much.
Make sure you, I think it's text. I don't know which, I think it's text. Okay. Either way, so again, this is good, but it's a bit long here. So this is respond, I put res. This I put R for row, make it easier for you guys. This is column for C. If you want, you can change that female and male is fine because there are not a lot, that's 6 to 4 characters long. But under 30, you have to do, under 30, I put under and over. Okay, I put you on this one. So make you, make things easier. Hello, you. And then the rest is under. Copy and paste this. So just this one is also under. Paste. And then for over, I use the letter O. Make sure it's categorical. That means that it has to be categories. So you cannot use numbering here. If you use numbering here, you will be having a tough time because you really did a lot of work here. Paste it here. And now I just copy this whole thing and then paste it into my notepad. Should open a new one. Okay. There, perfect. Save it. And then use your R. Again, you use a read table. The other kind of the same thing. You just do. And then I think A in this case is R, because if you use R, C, and res, you probably use the top arrow key and just, you know, like me, like here, I didn't even type anything. I just type it like this. So this is your R, your results for it. And we can do and see what's going on here. So you have to, there is not an interaction and there is, and so this is always no and this is always yes. Okay. Same thing effects. F in this case is 3.54. This is the one that you're looking for interaction. And p-value in 3 decimal places is 0.068. This is the last one that you're looking for. And since this p-value is greater than, we will fail to reject. So when you fail to reject, there is not, and there is not an interaction. So this one, you have to continue doing test 2 and test 3. So you cannot pick D in this case. So for this case, it has to be mean, not standard deviation. So anything with standard deviation is cut off. So the row values are, let me see what we have on this row here. Row, no effects and effects. So in this case, they have no effects and effects. So the row is same, at least one row, same, different. Effects means they are the same, equal. Yep. So same is this one. Okay. So same, equal. Then F, for find the F value here is the first one because that is your row. So it's 11.31 in 2 decimal place. And then for column, for p-value, it's going to be this one, 0.00, how many? 3 decimals, 2. So this number is actually less than 5%. So we will reject the null hypothesis, and that is sufficient. So it's either B or C. There is sufficient evidence to validation of a claim the row are the same. Not standard deviation. We don't use standard deviation. We use mean. Okay, we are using mean here for all the time for this section, chapter 12. And then this one is exactly the same for here, but instead of row, we use column. So no standard deviation, the same. So it's going to be B. And then the F is going to be the second one, the B. So in your R is 4.57. And then the p-value is 0.039. 0.039. 2 decimals, yep. And again, because this number is smaller than 5%, so we will reject. Again, we don't use standard deviation, we will use mean in this case. So now once you finish this, then you're done. So usually when you finish this, I will want you to do like the previous question that you have, I want you to do a final conclusion. Usually what is a final conclusion here is you say that there is no interaction between gender and age. You kind of conclude everything. There's no interaction. There is effects on the row, and there is effects on the column. So the final conclusion for this example that we did here is you just say that there is no interaction. So this is the final conclusion. There is no interaction between H and, you cannot use A and B because A in this case, I think is your H, and B in this case is your, what we have the other side. So you cannot use gender and H. So between gender and H, and then what you do, if you doesn't know which one is which, you just open up your table. You can tell that the female in this case is your row, and then the H in this case is your column. Okay, so there's no interaction, but you find out there is an effect. So there is an effect on gender, and there is an effect on H. And we are talking about pulse rate, right? Because these are all under is pulse rate. So then you say the pulse rate, just to make it nicer, it has no interaction between gender and age. The pulse rate has an effect on gender, and the pulse rate has an effect on age.
Would you say it the other way around, that the age has an effect on pulse rate and the gender has an effect?
No, we always do the pulse rate first.
Okay.
We always do the quantitative first. So we do the quantitative, which is Powell's rate in this case, and then we do categorical in this case. Okay. So what do you mean by if you do this conclusion? It means that if you put gender and age together, the Powell's rate has nothing to do with it. But if you just separate them between male and female, the Powell's rate has something to do with it. If you separate them between younger and older, the Powell's rate has effects on it. But if you put them together, no effects on both of them. So this is the meaning of this two-way ANOVA in this case. Okay. So this is something that you guys have to do if your project is a two-way ANOVA. This is, you will need to do a final conclusion. This is a final conclusion. How do you know your project is a two-way ANOVA? It's very easy. You have three hypothesis statements. That is an interaction between, does the Powell's rate has an interaction between gender and age? Does the Powell's rate has an effect on gender? Does the Powell's rate has an effect on age? So you have three questions like this in your project, means you're doing this 12.2 two-way ANOVA here. So I'm going to do the last thing we're going to talk about here. This is very important, is summarizing what you guys learned so far. Okay, so this is so important that I would recommend you guys to really pay attention. Also, if you like doing something else. So this is a part that I will summarize everything you learned so far in chapter 7, 8, 9, 10, 11, 12. Okay, so everything you learned. So first thing you ask yourself is, do you have one population? Do you have two populations? Or do you have more than two populations? Okay, so this is what you guys do when you read the question. Okay, if it's a one population, then you read, is this proportion or is this mean? How do you know it is a proportion? How do you guys know if a question comes as a proportion? Anyone?
The variable has a hat.
What hat? No.
No, not p hat. Mean has a bar over it.
But the question doesn't give you p hat. The question will not put down p hat right in front of the question. So
if it's a sample, then it's a mean, right? A sample is the mean and a population.
A sample can be a proportion too.
Okay.
So how do we know it's a proportion? Proportion is for categorical data. And in the question, you will have the word proportion. You also get percentage. Okay. For mean is for quantitative data. And in the questions, they will give you the word mean. Okay, so in the question, you will get the word mean in this case. Okay, so now once you get into this one population, if it's a proportion, then you have to figure out that are we talking confidence interval or are we doing hypothesis testing? Because if you are doing confidence interval, then you will do, you guys have a yellow index card for your R?
Yep.
Okay, I will show it to you what happens. Where's my, there you go, yellow index card for R. Okay. Towards the end there. So this is actually in chapter 7. So if you want to find a confidence interval for one population, this is number 16. So I just put a number next to him. So this is number 16. 16 means you use this library binom confid. But if you're doing a hypothesis testing for one population, proportion, you're doing number 18. That means you have to use what? You have to use StatCrunch. Okay. Same thing happens to the mean. So if it's a confidence interval, you have to do number 17, which is right here. T-test or library BSDA, depends the data given to us or the summary statistics given to us. If it's a hypothesis testing, then you do number 19. So these numbers are coming from the yellow index card that I gave it to you. And this is for one population proportion or one population mean. Now we got the same thing for two populations. So for two populations, you got either two population comes from proportion and two population comes from mean. If a two population comes from proportion, if you want to find the confidence interval for two population proportion is 20. That means you have to use StatCrunch. Okay. And if you're doing a hypothesis testing for two population proportion, where was that? There you go. Oh, it's also 20. So no matter you do confidence interval or hypothesis testing for two population proportion, you are still doing StatCrunch, so still 20. Okay. But mean here is a special case. Okay. So what? So I'm gonna put the mean here. So I put it down here. So when we talk about mean here, then you have to figure out special case. Are they independent or are they dependent match pair? Or are they talking about correlation or regression? So when we talk about two populations mean, we can, or quantitative variables here, we can talk about, are they independent, are they dependent, match pair, or are they talking about correlation regression? If they talk about independent, we also do confidence interval and hypothesis testing. So for this case, for the independent part, for the hypothesis, for confidence interval for two population mean independent, this is 21. For hypothesis testing that is independent, this is 22. Again, you are A/B, so watch carefully which one you do. For dependent, the hypothesis testing for this is, let me see, it's down right here. For this is not independent. For dependent is 22 and 23 and 24. Sorry, this is 23 and this is 24. So do not forget, for the dependent part, you have to figure out the D here. Yes, this is a special case because if you look at the 23, 24, this is D. Okay, but for correlation, you only do either a scatter plot. So scatter plot in this case will be number 25. So this is how you draw a scatter plot. Or if you want to figure out your R, your Y hat, all those goodies, your p-value and everything, this is number 26. So this is how you read your R in this case. Okay. If it's more than two, if it's more than two populations, and then you talk about either it's proportion or either it's mean. Okay. So for proportion, then you have to figure out, is that one category? If it's one category, is goodness of fit test, shortcut GOF, and that is number 24. If it's a two categories means that you got two of them, we call it as contingency table. Then either you test for independent or you test for homogeneity. And that is number 25 in your R. Test for independence, test for homogeneity. This is how you figure out. And this test for independence and test for homogeneity is for proportion. That is either you have one or two categories with multiple population. For mean, if you have one factor, this is what we just talked about. This is called a one-way ANOVA. One-way ANOVA. And this is 26. Okay. And if it's a two factors, then it is a two-way ANOVA. And in your R, this is number 27. And when you guys get this in your R, you can cancel, do not do the B part for one-way ANOVA because those are a bit more work. So for the B part here, you do not need to do this. Don't do this. I don't like that. Wait. So this one is no good. Okay. So when you do the B part in this case, don't do this. This is no good. And same thing for two-way ANOVA, don't do the B part. So one-way ANOVA and two-way ANOVA, ignore the B part, don't do the B part. Okay, don't do the B part, just do the A part in this case, like what I showed you in class, in today's work. So don't do this. You guys with me here?
Yeah, can you show that word? There you go. I'm just
Yep.
gonna take, are you gonna add more to that, or I'll just take a?
That's it. This is all you do, because this is chapter 7, chapter 8, chapter 9, chapter 10, chapter 11, chapter 12. I will post this in D12. This is how you make how do you do your conclusion for chapter 7, 8, 9, 10, 11, 12. So when you read the questions, if in the finals, figure out how many populations are we talking about. And then if it's one population, figure out are they proportion or are they mean. If it's proportion, figure out are they doing confidence interval or doing hypothesis testing. Then you know what is the yellow index card you have to pick. You guys all right here? So I will post this in D2L so you can know what is going on here. This is for conclusion for chapter 7, 8, 9, 10, 11, 12. All right, so anyone have any questions before I end the Zoom sections here? I will, if you have questions, your test, I resent it to you guys already in your email address, school email address. Your final is next Monday. It will be at noon. You got 24 hours to do it. It's all 50 multiple choice question. So on your finals is 50 multiple choice question. And I think I told you before about multiple choice question, right? I do not want you to show me any work. Just I want to see your answer. So usually what you do here in your multiple choice question, just type in question 1, answer is A. If you want to use Excel, you can use Excel. Question 2, your answer is B, E, no F, and like this. Then you just send it to me. So I just want to send your name and everything. So no, I do not want to see your answers. Your project is due on Thursday. Your project is due this coming Thursday because there are some students still doing a two-way ANOVA, which you just learned it today. Hope where your homework for that is due tonight too. So your project is actually due this coming Thursday. Then your test is due tomorrow. Your project is due on Thursday. You got finals that is due on that will be due on next Tuesday. So those are all it will be in. So make sure you give me. How do you do your project? Don't do Excel. Microsoft Word, anything that I can see, PowerPoint, and then send it to my email. If I can view your project, I will reply back to you saying I got your projects and I can see it. If I cannot see it or something happens, I will email you back and I will say, hey, I cannot read I cannot open up your file because something wrong, or my computer cannot open it. So when you send me a project, don't just, oh, I did my project, oh, I can rest. No, just wait for another 30 minutes. I will send you back another email. If you get a confirmation email saying that I received your project, you're good to go. If I didn't get any email back from me, or if that means if I didn't get email back from me, means I haven't got your project yet, means your email is sent to somewhere else. I don't know where. Or if you get an email back saying that I cannot open it or something happens, please make sure that you guys quickly convert it back to like Words or Excel or Word or PowerPoint or something, documents that I can read. Okay, otherwise you get a 0 in the test, in the project. Anyone have any questions here so far before I end this?
I had a question on the project.
Okay, question projects, we can wait because I'm gonna unrecord this. All right, so I'm gonna let you guys, if you have questions, stay. If